Okay. So, before we talked about speed, and I gave you an equation, now we're kind of going to get into some more details related to speed, because there's two ways of thinking about speed. So, instantaneous speed is your speed at any given moment, like at 3 minutes, 24 seconds, and 100 milliseconds into your trip. Your speed is blah, blah, blah. Alright? Whereas your instantaneous speed is constantly changing. Like if you consider driving, if you're on, Scottsdale and going 50 miles per hour, odds are what's happening is occasionally your odometer is going to maybe 51, 52, occasionally it's dropping down to, 49, 48, and your instantaneous speed at any given moment is constantly fluctuating. Whereas if you think about that based on our equation and our average speed, so that equation that we learned about is actually calculating average speed all the time. If you go 500 meters down Scottsdale in 60 seconds, your average speed is the 500 meters divided by the 60 seconds, or your total distance divided by your total time. Alright, so there you would need your odometer and how long you've been going and the time that you went. Alright, so we've already practiced a lot with average speed, so I'm not going to drill that into your head again, but what we're going to learn is how you can figure out instantaneous speed. And that's easiest if you have a graph. Alright, here you can see every time the graph shape changes, you have a different distance being traveled in a different amount of time. Alright, so if you look at each second of time and the distance that is being traveled, it changes for each second. So that's how you can figure out the instantaneous speed, say between 1.5 seconds. You just need to find the slope of the line. Okay, so for those of you that don't remember this from math class, the slope formula, you need 2 points. So point 1 is x1, y1, point 2 is x2, y2, and then you just plug it into this equation. Know this, be friends with it, you will use it. Okay, you will be finding slope lots and lots of time because the slope is almost always a really, really important concept. Okay. If you remember from our dune buggy lab, and let me make this so you can actually see the x-axis before, when we plotted time and distance, we calculated the slope, and that slope always tells you your speed. That slope, if the slope is changing, it can give you your instantaneous speed, or if it's not changing, then it's one constant speed for the entire period of time. Alright, so let's find our speed at 3 seconds. So in order to do that, we need to know what this point is and what this point is. Alright, those are pretty easy to read off the graph. So our first point is going to be the 2 seconds and the, 3 meters. And then our second point is going to be the 3 seconds, because that's our x value, and 8 meters. Alright, and then we plug that into our slope formula, which is y2 minus y1, x2 minus x1. Okay, so let's do our y's, 8 minus 3 over 3 minus 2. And if we simplify that, we get 5 over 1, which is equal to 5. Now, if you're using a graph, you use the units on the graph to figure out your units for your speed. So our distance was in meters, our time was in seconds, so these were meters over seconds. So our final answer is 5 meters per second. Okay, pretty easy. Just got to get familiar with slope formula. Alright, and you'll be doing some graphing practice if you choose to do the assignment, which I highly suggest. Takes a little bit of time, but you'll have some time in class. So take care of it, get your extra 10%. Alright, see you in class tomorrow. Oh, and one quick reminder, there is an online assignment that does need to be completed if you want credit towards this. Okay, So make sure you do the online assignment. There, however, will not be a quiz in class. Okay?